Hello. This lesson covers true bearing and direction. What is true bearing? True bearing shows how much we rotate from north. To be more accurate, when I want to find the true bearing of point B from point A, I draw a line from A towards north. So this line from A is drawn towards north because I want to find the bearing of B from A. From the second point, you draw a line in north direction, in the direction of north. And then connect A to B, because we are talking about points B and A. Connect them with a straight line. Then ask yourself, that line in the direction of north needs to turn by which angle to fall on AB. So this line, if I want to rotate it in a clockwise direction, how much it needs to turn to fall on AB. So basically you're turning this northerly line around point A and it falls on AB. The only point that you need to be careful of, you got to turn in a clockwise direction, not in anti-clockwise direction. In a clockwise direction. Alright, so in this question they are asking us find the true bearing of point B from point A. So point B from point A. So draw a line in the direction of north from A, and then see how many degrees you need to turn. And in this case it is 110. So we say the true bearing of B from A is 110 degrees. And we use 3 digits to show that. So even if it was 10 degrees, I would have written 0, 10. Next question, find the true bearing of M from Q. That is M, that is Q. M from Q. So they are saying from Q, so we got to draw the north line from Q. That's the north line we have here. Now, if you remember, we said that this north line needs to turn in a clockwise direction to fall on QM. So you're turning it around Q and it falls on QM. How many degrees that should be? We have been given this angle, but we need this angle. Remember that the whole thing is 360. One full revolution is 360. So I need this much, which makes a full revolution with 125. So then this side is 360, take away 125. 360 take away 125 is 235. So we say that true bearing of M from Q is 235 degrees. Now we can use this in combination with trigonometry. This example looks at that. A car drives from Sydney on a bearing of 200 degrees for 250 kilometers. How far west of Sydney is the car? Alright, so this is Sydney, we've shown with S, and the car has been driving on a bearing of 200 degrees. So that is 200 degrees. In that direction, it's been driving for 250 kilometers. and now it has reached here. So left Sydney and went in that direction and reached the point P. We want to see how much west of Sydney is this point. To answer this question, we got to make a right angle triangle. From here, I've drawn a line in the direction of west. This is westerly direction because they want us to tell them how much west of Sydney is this point P. All right, so a line in the direction, in westerly direction, and then you make a right angle triangle by dropping a perpendicular line from P to that westerly line. All right, now we have this. They told us that that was Sydney. From Sydney, it's been driving in that direction by 250 kilometers. So this is 250 kilometers. And they said that the true bearing is 200 degrees. So that's the true bearing. But we need this angle. Remember that this whole angle from north all the way to this west is 270 degrees. This angle, the whole angle, is 270 degrees. And this is 200 degrees already, so 270 take away 200 gives us 70 degrees. So 70 degrees left for this. Now we use trigonometry. So this is adjacent, this is hypotenuse. They make cos. So we write cos 70 is x, which we want to find, over hypotenuse, which is 250. Adjacent over hypotenuse. Now we times 250 by cos 70 to find x, and you type that in your calculator to get 85.5 kilometer to 1 decimal place. That's all for this lesson. Thank you very much for your attention.